Hi, my name is Ryan. I'm joined by my colleague Karthik, and today we're going to talk about Amazon DocumentDB. So we'll talk about Amazon DocumentDB. We'll walk through some case studies. We'll talk about what's unique about DocumentDB from an architecture perspective. We'll go through a little bit about what's new, and then give you some next steps in terms of DocumentDB. So AWS has the broadest offering of cloud services across databases and analytics. And we take a Swiss Army knife approach to these services. The service you will use typically depends on the use case. Broadly speaking, we offer relational databases, and these are for customers wanting to move away from self-managing their Oracle, SQL Server, MySQL, Postgres, Maria databases. We offer Amazon RDS and Amazon Aurora for these types of workloads. We also have a set of non-relational database services, and these are for customers wanting to move away from self-managing their non-relational document or key value stores, such as MongoDB, Redis, Memcached, etc. And we offer DynamoDB, DocumentDB, and Elasticache for these types of workloads. For customers that want to move from their expensive proprietary Teradata, Oracle, and SQL Server data warehouses, AWS offers Redshift. And for customers wanting to move their on-premise Hadoop and Spark deployments, either for cost savings or having a managed service, AWS offers EMR. For customers that want to move from their expensive Elasticsearch, Logstash, and Kibana, typically referred to as the ELK stack, to a managed service, we offer the Elasticsearch service. And for customers that want to move their Apache Kafka deployments, we offer the Amazon Managed Streaming for Kafka service. And finally, customers that want to move from their Tableau or SAP type of applications, we offer QuickSites. So what is DocumentDB? DocumentDB is a fully managed, scalable document database service that supports MongoDB workloads. It's fully managed, so it's managed by us. There's no hardware to provision. It's easy to set up through the console, and you can spin up a cluster in minutes. We've got built-in high availability. Clusters are automatically provisioned across multiple availability zones. Our best practices are enabled by default. So for example, backups, we don't allow you to disable backups because we believe that's a best practice. From a durability perspective, your data is copied 6 ways across 3 AZs. You're only paying for a single copy of that data, but the 5 additional copies are stored for free. And then from a security perspective, you can use identity and access management and built-in role-based access control to enforce least privilege access. Patching and maintenance are handled automatically by the service. And we have native integration with other AWS services such as CloudWatch for monitoring and setting up alarms, and CloudTrail for logging and auditing. And these native integrations help to simplify your tech stack. Our customer, FINRA, use DocumentDB without any overhead from their engineering teams. DocumentDB is scalable, so separation of compute and storage allows you to scale both of these aspects independently, and Karthik will talk a little bit more about that, what that means from an architecture perspective. You can scale compute horizontally or vertically in a matter of minutes regardless of the amount of storage in the cluster. Storage and I/O auto-scale from 10 gigs up to 64 terabytes, and there's no need to worry about taking care of additional EBS volumes or scaling an on-premise SAN when you're utilizing DocumentDB. And you can scale out your up to 15 read replicas in a matter of minutes. Iron is another customer with DocumentDB, and they can scale their cluster in minutes regardless of the data size. And finally, we're MongoDB compatible. So we're compatible with MongoDB 3.6 and 4.0. You use the same SDKs, tools, and applications. We support hundreds of APIs and operators and aggregation stages. And we work backwards from our customers. We start with you and get feedback on the product, which is fed back into our engineering teams to implement feature requests. Our customer Freshworks love the fact that we are compatible with MongoDB, and their application required 0 code changes. So when is a good time to use a document database? Well, probably the most obvious is when you're working with JSON data. So document databases store data in a JSON-like format. And JSON is flexibly structured and maps naturally to how we think about data. We typically don't model data in tabular formats in our head. We're thinking about groups of things instead. You would use a document database when you have a requirement for a flexible schema. So with document databases, there is no need to design a complicated rigid schema. The schema can change depending on our data needs and access patterns. If you're looking to do ad hoc querying and you want to retrieve specific values and fields and work with regular expressions, DocumentDB is a great use case and example of that. We also use a JSON-like query language, so it's really easy to learn. And flexible indexing. So indexes in a document database can be created and dropped on demand and can be declared on any field within your documents, including fields nested within arrays. So many customers across different industries and verticals are utilizing DocumentDB. We've been GA since January of 2019, so a little bit over 2 years in the market. We have a lot of customers that are running mature workloads on DocumentDB. Anywhere from a small startup to a Fortune 50 customer will use DocumentDB for their production workloads. In terms of use cases, DocumentDB spreads across a variety of different use cases. So when you look at content management, so a lot of the content that we read today, from news articles to blogs to recipes to patient records, all of that data lends itself really well to a document model since it's dynamic and changing. Mobile is another great example. It's very easy to store data that you collect back and forth between mobile devices because JSON is a de facto standard for data interchange. Catalogs, being able to record the outputs of machine learning experiments, inventory descriptions, pharmaceutical trials. We see a broad set of customers that use documents for these types of use cases. And then gaming, storing user profiles, game management, and matchmaking. These are all great examples of DocumentDB use cases. Anytime you have a complex document that's dynamic and changing and requires ad hoc querying, indexing, and aggregations is a great example of when you might use DocumentDB. I want to transition now and talk a little bit about a case study. So Rappi is a current DocumentDB customer. They're a startup. They're very similar to DoorDash. And this is an app that handles restaurant orders, grocery delivery, and clothing delivery as well. So their business problem is that they were seeing an explosion of growth, and they had a popular delivery service that experienced a lot of different outages in their prior environment. They had built a monolithic application and needed to support a more flexible and microservices-driven approach. They were also seeing slow performance from their prior system, and it affected thousands of users. Sometimes queries were taking up to a second or more to complete. So they were looking for a service that was compatible with MongoDB. They also wanted to independently scale their microservices. Their prior architecture had a huge Elasticsearch cluster for all of their different business units across different countries. But most importantly, they wanted to get out of the infrastructure management business and eliminate the undifferentiated heavy lifting that goes along with maintaining your infrastructure. So the solution was that Rappi created a single cluster per business unit, and this gave them the ability to scale their microservices. The horizontal scaling of read workloads reduced the query latency quite a bit. And you can see here from 16 times from 500 milliseconds down to 80 milliseconds. And with minimal code changes, they were able to migrate from MongoDB to DocumentDB, resulting in 60% of FTE cost savings. So the solution advantages, since implementing DocumentDB, they've had no outages. Their largest cluster took 2 weeks to migrate, but then after they got through the migration process, they were able to perform over 100 migrations in less than 3 months. But most importantly, Rappi now has only 2 engineers managing their entire DocumentDB employment. This reduced their operational overhead substantially and allows the engineering teams to focus on value-add activities. So I'm going to pass it over to my colleague Karthik to talk a little bit more about Amazon DocumentDB architecture.
Thank you, Ryan. Hello, folks. My name is Karthik Vijayaraghavan, and I'm a DocumentDB Specialist Solutions Architect with AWS. I'm going to be talking about Amazon DocumentDB architecture today. We will discuss the architectural components. I'll focus on some of the salient features as listed on the stack. I will walk through the stack and show demos and code samples and console overview to show how DocumentDB works. At a high level, DocumentDB is architected to separate storage and compute so that they can scale independently. I'll use this diagram throughout the presentation to discuss the features and core capabilities of Amazon DocumentDB. Before we get into the stacks and the various capabilities, I would like to show you a console overview to see what DocumentDB cluster creation process looks like and the various features and capabilities in the DocumentDB admin console. So let's start with a console overview. All right, so I'm here in the Amazon DocumentDB console, and you see that I have one cluster over here, and this is the landing page, and I'm in Ohio region. So let's go to the cluster. So I've already pre-created a cluster, but let me show you how to create a new cluster, and then I'll walk you through this pre-created cluster. So click on the create button over here and give a name for your cluster. Let's call this to be getting started. And I'm going to choose the engine version 4.0, which we released last November. The other older version is 3.6. I can choose an instance class, and there's like a wide range of options over here, all the way from 2 vCPUs and 16 GB RAM to 96 cores and 768 GB RAM. We also have this T3 medium instance, with 2 vCPUs and 4 GB RAM. I'm going to go ahead and use that for this demo. And you can choose the number of instances. I'll just say 1, but you can go all the way up to 16. So you can have 1 primary and 15 read replicas. I'm just going to say 1 instance for now, and you can give the username and password. So like that. And that's the minimum set of fields that you need to provide to create a cluster. Let's take a look at the advanced settings, because more often than not, our customers do create DocumentDB in a VPC of their choice. So DocumentDB is a VPC only service, and you can select a VPC at the time of cluster creation. So I'm going to choose this VPC that I've already created. And as you saw, the subnet group automatically populated. Subnet group is basically a collection of subnets within that VPC where you want your instances to be distributed. So let's say each subnet group has 1 availability zone, and you pick a subnet group with, our recommendation is to pick one with 3 availability zones so that your instances are distributed across those availability zones. And then comes security group. A security group is as you may know, it's a virtual firewall for in front of the DocumentDB cluster here, and it helps you to minimize the surface area of attack. So I've already pre-created a security group called DocDB inbound, which allows inbound request from a specific set of application servers over port 27017, which is the default port for DocumentDB using TCP protocol. So by this, I'm telling that nobody other than those application servers can talk to my DocumentDB. So I'm minimizing the surface area of attack. So I'll leave the port as default 27017, and cluster parameter group. You can either use the default cluster parameter group, or I've created a cluster parameter group, and I'll walk you through these and the subnet group as well. So when you need to create when you need to publish audit logs or profiler log, you need to enable that first, and by default they are disabled, and the customers would enable that as and when they need it. So you can create a cluster parameter group, and you can enable audit log, profiler log, chain streams, and all that stuff. So it's all configurable for you. And then encryption at rest, the default value is it's enabled. So when it comes to security, all the default settings are, they adhere to the best practices. And here we are using KMS key and provided by Amazon. So for encryption at rest, we integrate with KMS, and by default, your Amazon provided key is available. But if you want to bring your own key, you can do that as well. Backup by default is for 1 day, but you can, depending on your retention period, choose any value between 1 and 35. I'm going to leave it at 1. I'll say that the backup window is about midnight, so this is where the automated snapshot will be taken. But again, keep in mind the backups in DocumentDB are continuous and incremental, so that you can take do point-in-time recovery. And now logs. So you can choose to publish these logs to CloudWatch, and so that you can then go and use log insights and perform further analytics on those logs. Maintenance window. DocumentDB is a fully managed service, and you can choose a maintenance window so that we will use that to apply upgrades and patching and stuff like that. So I typically like to do this maybe 1 a.m. on a Sunday, so that there's probably very less usage for the system. And last but not the least, tags. Tags are best practices. Again, when you use tags, then you can use them for things like cost allocation tagging, so that you can take a look at which resources associated to which tag is contributing to the cost, right? So that's a good practice to tag your clusters. And then deletion protection is enabled by default. This ensures that nobody accidentally deletes your cluster. You can delete individual instances, but when you try to delete the last instance, you'll get an error saying that, hey, this cluster has deletion protection enabled. So if you want to delete the cluster, then you'll have to come over here, uncheck this, and then delete the cluster. So with that, I'm just going to go ahead and say create cluster. So as you can see, getting started cluster is in creating status. Like I said, I have already pre-created a cluster, so let's go and walk through that. So the first tab here is connectivity and security. You can see that there are a couple of connection strings. So if you want to use Mongo shell, you can just copy the string and replace the password. And if you're using an application, Java, Python, Node.js, whatever that is, you can copy this connection string. And this has all the best practices in place, and I'll talk about this later in the presentation. The security group is DocDB inbound that we selected at the time of cluster creation is over here. So if you look at what this security group contains and how it is configured, it's fairly straightforward. It just has like one inbound rule, like I said, TCP protocol and 27017 port, and accept anything that comes from this security group, where my app server, in this case, I'm using Cloud9 as my app server. So I'm going to say that any request coming from this app server on this specific port, please do allow that DocumentDB is what this means. So let's go back to our console here and look at the instances tab. So here you can see that I have two instances. So for this cluster, I've created a primary and a replica instance of R5 extra large, and I can do more further operations, which I'll do in subsequent demos on how to scale and stuff like that. But this view gives you the list of instances. And the various configuration options we selected at the beginning, you can see them over here. You can modify to change some of these, like if you want to change the security group or backup retention period, maintenance window, you can do all that in the cluster. So let's go back to the cluster view and monitoring, right? So this cluster, you can view monitoring metrics at this cluster level here. And there are more than 50 metrics that DocumentDB provides. You can either view them here, or you can add them to dashboard and view them in CloudWatch. And then events and tags gives you, the tag that you created at the time of cluster creation. And then, if there are any recent events, which there is none for this cluster. And then if I go through this menu on the left, we saw whatever is under clusters. Like under snapshots, you would see that there is one snapshot. Again, this has a backup retention period of 1 day. So it creates automated snapshots on a daily basis. So the last snapshot created was, on this particular date. And then like subnet groups. So I use this subnet group for while creating the cluster. And you can see that there are 3 subnets, and each subnet has one availability zone. So any instances we create are going to be distributed across these availability zones. Parameter group, we chose the cluster parameter group, and you can see that this has audit log, profiler log, all enabled. So you can choose what should be the threshold for the queries. If it is like 100 milliseconds, we are going to be logging 100 milliseconds or more, the queries that take 100 milliseconds or more to the profiler log. And then events will give you all the events for all the clusters in this region, Ohio. And then we have like what's new to educate customers on what we are launching, and some tutorials to get your hands dirty. So that's about the console overview demo. So let's go back to the presentation now and look at the various architecture components. Thank you. All right, so I hope you enjoyed the console overview. Now I will start with the first component in the stack, which is compatibility. Amazon DocumentDB is compatible with MongoDB APIs. You can use the same tools, drivers, and applications to develop against DocumentDB. As shown in the slide, an application here sends a query to DocumentDB using MongoDB's Find API, and you can expect to get the same response that you would have received from MongoDB when you query it against MongoDB. So let's take a look at a basic application. This application connects to DocumentDB, inserts a record, and reads the record back. It's a very, very, very simple application built using MongoDB driver. So let me go to the Cloud9 environment and show you how this application works. I'm here on the Cloud9 environment. Cloud9 is basically, think about it like an EC2 running on a browser. It's convenient to show code samples and move files back and forth. So I choose Cloud9 environment over EC2. So here is the code sample that I was showing earlier, and all that I'm doing here is connecting. I'm getting the secrets from Secrets Manager, but before talking to DocumentDB, I'm going to be talking to MongoDB. So this line of code connects to MongoDB running locally on this server. And I'm just going to be doing an insert operation, and then I'm going to be reading that data. And once we are done, I'll come back here and switch the connection string and do the same operation, just to show the compatibility aspect of DocumentDB with MongoDB. Let me go to this tab, and I'm going to say Python 3, and I call this a sample app. So as you can see, I did insert a document, and then when I read this document, I got this document value back, X Amazon DocumentDB, with an object ID. Now let's go back to our sample app, and we will just uncomment this connection string, and we will comment this connection string over here. So all that I'm doing is just swapping the connection string from MongoDB to DocumentDB. And I'll walk you through this connection string and the various parameters over here as we go through this presentation today. So the rest of the code remains the same, saving it, and I'm just going to run the same command. As you can see, now we performed an insert operation and a find operation against DocumentDB. We got the exact same value. The object ID is going to vary from a system to system, but what you write into DocumentDB, into MongoDB earlier, is what you got back. So you got exact same results. That's what we mean by compatibility. We'll now talk about separation of storage and compute, the second component of the stack. Amazon DocumentDB was launched in 2019, and when we built the service, we took the opportunity to purpose-build this architecture to leverage the scale of the cloud. DocumentDB is built from ground up as a cloud-native database service, and it adheres to the best practices of the cloud. When you look at traditional database architectures, they are built as a monolithic architecture that runs locally on a server. The database process does everything from receiving and processing queries, caching, logging, persistence, and so on. And the storage is attached to the instance, and to scale this architecture, you'll have to copy the entire stack, just like this. This is a typical challenge we hear from our customers, especially around moving data, because moving data is literally painful, and this scaling process makes it all that painful. And it takes days or even weeks, depending on the volume of data and the network performance. To address this challenge, we separated storage and compute. As shown here, storage and compute are separated to two distinct layers. The compute heavy work, like handling API requests, query processing, caching, all of these are offloaded to the compute layer. And work like replication, backups, all those are offloaded to the storage layer. And then instead of sending 8K pages to the storage layer from the compute, we send log writes with specific changes, and the storage layer reconstitutes these pages. So separating storage and compute layer helps us to break apart the monolithic architecture, and it lets you to scale compute and storage independently. We can start with a simple T3 medium instance and then scale as needed. We will discuss later in this presentation on how durability is not a function of the number of instances in the cluster, and a single instance, as shown here, T3 medium instance, will provide you very high durability. Starting with T3 medium is very common for development purposes, and we recommend doing that. It helps you save cost. As your workload grows or your environment matures, you can scale your instances up and out to get more compute and memory. Let's say to R5 large in this case, where you scaled up from T3 medium to R5 large to get more memory and compute. As the compute and storage are decoupled, scaling does not depend on the storage size and completes within minutes. We typically say it completes in about 8 to 10 minutes. You can add new instance for high availability or for read scaling. With 3 instances, as shown here, you get about 4/9 of availability. With DocumentDB's cloud-native architecture, scaling out or scaling up of instances does not depend on data volume, and it can be done irrespective of the storage size. We see our customers scale up their instance to run complex analytical workload and then scale it back down. As you see in the slide, you can run a larger instance to process those heavy queries, and then either delete them or scale it down. We also see our customers scale their cluster during peak hours and then scale it back down. DocumentDB's architecture provides the flexibility to accomplish this kind of scaling without worrying about the time it takes, especially for workloads of large, with large storage size. And the extent to which the storage and compute are decoupled is that you can delete or stop all your instances and still have a highly durable storage. You will not be able to query this, of course, because there's no compute, but you can store the data durably. And when you have a need to query, you can just add an instance or multiple instances and start querying. We launched a capability called Start Stop Cluster that allows you to stop the cluster when you don't use it and then start it when you need it. Let's take, for example, a development environment, right, where there's not much work happening over the weekend. Stop those dev clusters over the weekend and then start them back on Monday. You save 2 days of cost on the instances. Thus, separation of compute and storage not only helps with scalability, but it also can help with cost savings. So now let's take a quick look at the console. I'm going to show you a demo where I'm going to be adding a new instance. Basically, I have pre-created a cluster with couple instances, and I'm going to scale this cluster, and I'm also going to take a backup. And this cluster has about 12 terabytes of data. So what I'm going to show you here is a live demo where I'm going to scale a cluster which contains 12 terabytes data, and at the same time, take a backup. So with that, let's go to the Amazon DocumentDB console to take a look at this demo. Okay, so I am here in the console, and I have the demo cluster here. So before I perform scale, operations, and backup, let's go to the monitoring tab and take a look at how much data we have in this cluster. So like I said before, we have about 12 terabytes of data in this cluster. You can see that in the volume bytes used metric. All right, so let's go to the cluster and let's add another R5X large instance to this cluster. So I selected this cluster and I'm saying add instances, and I'm saying R5X large. Again, a best practice is to keep those instances homogeneous. So I'll just use the same instance class and I'll say create. So you can see that the third demo3 instance over here is in creating status. All right, let's also go to the snapshots menu over here, and let's click create. We're going to create a snapshot for our, you can pick and choose the cluster. In this case, the demo cluster is the one that has the 12 terabytes data. So I'm going to call this as demo snap. You can give any name here and say create. There you go. So the snapshot is being created, and you can see that it is categorized as a manual snapshot. So we'll come back to this, after a while. Let's go back to the presentation and take a look at the other architectural components. So let's move on. We'll look at the next component, which is replication. One of the advantages of DocumentDB's architecture is that replication is offloaded to the storage layer. This will free up the instances for more read capacity and query processing. When you write data to DocumentDB, you will write to the primary instance. The write operation will replicate the data across 3 availability zones, as you will see in this animation. So you see the data in the first block over there, the second, third, and fourth. DocumentDB uses a write quorum of 4. After 4 copies of data is written to the storage, the primary instance will send an acknowledgement back to the client. The primary instance will also replicate the data to the replica instances to keep those instances up to date with the latest data. If the replica instance don't have the data resident in their memory, then we don't pollute the buffer cache, allowing each replica to manage their buffer cache. And while this is happening, the data is further replicated to maintain 6 copies of data across 3 availability zones. And since storage layer handles the replication, the replica instances are freed up to perform read operations at scale. As a best practice, we recommend that you connect to Amazon DocumentDB cluster as a replica set and use the read preference as secondary preferred. This setting will allow you to scale your reads by leveraging the read replicas while allowing the primary instance to focus on handling writes. Since storage and compute are segregated, decoupled, and durability is offloaded to storage layer, you can use the replica instances to scale your reads for complex queries without impeding the durability, as long-running analytical queries will not block your writes because they just go to a separate instance. So let's take a look at the code again. In this demo, I'll show you how we connect as a replica set to scale reads. So I'll just do a quick code walkthrough that we started off in our one of the first demos. I'm back at the Cloud9 environment. I'm at the sample app Python file that I started off in the first demo. So here you can see that the connection string for DocumentDB, initial attributes or configuration parameters here are about the post and port and username password. We get all this from a secrets manager. So that's a nice and clean way of doing it so that you don't, use credentials in your code and rather get it from secrets manager. So it's nice decoupling there. And I'm connecting with SSL enabled, and I'm passing the cert as well. So the replica set that I was mentioning earlier is over here. So this is how you connect document from your application. You connect to DocumentDB as a replica set, right? So you use, say, replica set equal to rs0, and then give the read preference as secondary preferred. So with this connection string, what happens is when you perform inserts, the write operation goes to primary instance automatically. And then when you do a find, the read operation is routed to one of your read replicas, right? So all the available read replicas, participate in this, and your driver would send the request to one of the instances. And as you add more read replicas, they automatically participate in supporting the read operations. So that's how you connect as a replica set with read preference secondary preferred. Moving on, let's talk about durability. Storage in Amazon DocumentDB scales automatically and increments in 10 gigabyte segments. By default, the data is replicated 6 ways across 3 availability zones for high durability and resiliency. Let's walk through a scenario. If one availability zone goes down, this is again very, very rare and would be a bigger issue than just DocumentDB. But let's say if one availability zone goes down, we will still be able to achieve the write quorum, that is creating 4 copies of the data, which is required to send an acknowledgement back for a write operation. Read operations, on the other hand, requires a quorum of 3, so read operations will not be impacted by an AZ failure as well. So in a nutshell, even if one AZ goes down, Amazon DocumentDB cluster would continue to perform just like as it was before. And now let's say another copy of the data in another availability zone is lost. Now we lose the write quorum because there's one AZ down, 1 copy of data down, and there's only 3 copies, so there's no write quorum of 4, but read quorum is still available, and you can still read data from the database. So with 1 AZ and 1 data copy being lost, you can still read from the database. DocumentDB stores data in 10 gigabyte segments, and when failures like these happen, the mean time to recovery becomes a function of replicating these 10 gigabyte segments or partitions instead of a monolithic architecture where you have terabytes of data. So the mean time to recovery is the time it takes to copy 10 gigabytes of data over the network to rehydrate another copy of storage. When using a distributed storage as opposed to a monolithic disk volume, mean time to recovery is orders of magnitude faster. So now let's take a look at a quick demo, which is again going to be a quick code walkthrough on write concern. I'll show you how DocumentDB durably stores writes into the cluster. Okay, I'm back at the app here, and in the connection string, you see that the write concern and journal are commented. When you perform a write operation in DocumentDB, you can be rest assured that the data is going to be durably persisted. And to facilitate that, we use write concern as majority and journal as true, regardless of the value that you pass in. So if you pass write concern as 1, we will override it to be write concern as majority and journal as true, so that your writes are durably stored in DocumentDB. Let's talk about backup. Backup in DocumentDB is different than how traditional databases perform backups. DocumentDB has a no impact to backup because we stream the backup from storage layer to S3. We perform continuous, incremental, and full backups to S3 so that we have a fine granularity with incremental backup and a fast restore times with full backups. As you can see in this slide, I have not included any compute instance that shows that we're taking a backup. This is because compute instances in DocumentDB do not participate in backup. Backup is offloaded to storage layer, and this further frees up compute instances to perform query processing and read-heavy workload. So if you want to take a backup of your production system, you don't have to worry about backups bringing your system to a grinding halt or impacting your application's performance, as backup is happening at the storage layer and not at the compute layer, which directly interacts with your application. We are always streaming to S3, and DocumentDB has backup enabled by default. You get 1 day of backup at no charge to you, and when you whether you configure this backup or not. And when you configure backup, again, you can choose a backup retention period all the way up to 35 days, and you'll be able to restore from this backup, and you can perform point-in-time recovery with DocumentDB. So let's go back to the console and check how our scale and backup operations are doing. We started this about maybe 7-10 minutes ago. So let's take a look at the console to see where we are with this process. So I'm back at the DocumentDB console, and let's go to our demo cluster. So initially we had 2 instances, and I added the third instance. If you remember, I clicked on this and I said add instance. So this third instance is now, it was in creating state when we left it here earlier, and now it's in available state. So this instance is available, and it automatically participates in supporting the read request that comes from your application with no changes to your application whatsoever. And then, let's go to the snapshots. So I initiated this manual snapshot and we named it demo snap, and you can see that its status is also completed. So in about 7-10 minutes or so, we scaled our cluster. We took a backup without impacting any real time operations to the cluster. That's the power of segregating compute and storage layer. All right, so we created a 12 terabyte snapshot and scaled our cluster in less than 10 minutes, which is pretty remarkable. So let me quickly summarize on what we have discussed in the last 20-25 minutes over here. We discussed about how DocumentDB's cloud-native architecture helps to scale and scale compute and storage independently by decoupling them. While DocumentDB is available to you as a service, internally it's a group of microservices performing different tasks such as query processing, replication, and so on. Monitoring is integrated with CloudWatch, and so are CloudWatch alarms. All of this is available as a single package to you as a fully managed service. We saw how compatibility with MongoDB helps to build or migrate applications to DocumentDB, and replications and backups are offloaded to storage, freeing up instances to perform more compute-heavy work. Durability is built in by default by replicating data 6 ways across 3 availability zones, leveraging the cloud infrastructure. That is DocumentDB for you guys. And with that, I'll give it back to Ryan, and he'll talk about pricing and some of the cool stuff we have released in the recent days. Thank you, everybody.
Thanks, Karthik. Now let's talk about pricing. So with DocumentDB, we price the service across 4 different dimensions. The first is instances. So it's the size of the instance and the number of instances that will determine your cost. And in US East 1, our pricing is 7.8 cents per hour for the T3 medium instance. We charge per hour, but we bill down per second. So the first 10 minutes is a minimum when you start your cluster, but after that, we bill down to the second. You can also stop the cluster to stop billing on your instances. However, we'll restart that automatically after 7 days to ensure that you're up to date with the latest patches. The next dimension that we charge on is pricing, IO. And so with IO, it's 20 cents per million. And we charge we do writes in 4K chunks and then 8 reads in 8K chunks. We group IO together. So if you're doing multiple writes one after the other, say multiple 1K writes, we'll group those together and then only count that as a single IO operation down to the distributed storage. So the storage is the third dimension that we price on. We charge 10 cents per gig per month. As I mentioned before, we store your data 6 ways across 3 AZs for durability purposes, but we only charge you for a single copy of that data. So if you have 10 terabytes of data, you're only getting charged for 10 terabytes, but we actually have 60 terabytes of data stored in the distributed storage volume. And then backups are the final dimension that we price DocumentDB on. So with DocumentDB, we don't allow you to turn backups off. So because of that, we'll give you up to 24 hours of a window for backups for free. So if you're storing, again, 10 terabytes of data in the cluster, you can store that data for free up to the 24-hour window. If you increase the window, you'll be charged an additional charge at 2.1 cents per gig per month. And you can increase that window from the 24 hours up to 35 days. If you need data around for longer than 35 days, then you can take a manual snapshot and that will stick around for as long as you need it. So what's new in DocumentDB? Mongo 4.0 transactions. So we launched ACID transaction support in November of last year, in 2020, along with MongoDB 4.0 compatibility. So you can use DocumentDB to perform transactions across collections or databases. And then new operators and performance improvements, working backwards from our customers' needs. We continuously add more operator support, aggregation pipeline stage support, and we've made several improvements to our indexing capability to help improve performance of the queries. In addition to these releases, we've come out with T3 mediums for better pricing. We've increased our connection limits. We have new region support and many other features that have been released in the past year, and we'll continue to add capabilities to help our customers move more and more workloads to DocumentDB. So what's next? We will continue to work backwards from our customers' needs. You can look at a few really important pages here that we've displayed. So the first one is a resources tab, and this keeps track of announcements and additional blogs that we've written on DocumentDB. You can also use our workshops to learn more about DocumentDB by leveraging our Immersion Day workshops. And so these are workshops that are done on site, virtual for now, but usually done on site. And we'll go through a DocumentDB overview similar to this. We'll also go through a best practices. We'll show you how to size your clusters and choose the correct instance types. And then we'll do a segment on migrations for your clusters and show you the best practices behind migrations. These are great workshops to learn more about DocumentDB. We also include labs in these workshops. They're optional, but in the labs, you can stand up your own DocumentDB cluster. You can scale the cluster. You can do, we'll show you how to do simple CRUD operations, and then add on some monitoring and some alarms if you'd like to see how those work as well. And so with that, I want to thank you for listening to this presentation on DocumentDB, and thanks again.
In this section, we will discuss about the best practices for Amazon DocumentDB. We're going to cover a wide range of topics from cluster sizing to security. We'll talk about how to scale, how to monitor DocumentDB, some cost optimization techniques and some indexing optimization ideas. And we'll also talk about how to connect and the best practices around all of these. So let's jump right into it. DocumentDB is architected to separate storage and compute so that they can scale independently. Storage scales automatically, and compute instances can be scaled up or out as required by a workload. And the data in the storage layer is replicated 6 ways across 3 availability zones for high durability. So let's start with the first topic in the agenda here for best practices, which is sizing. The number of instances in a cluster determines the availability target. With one instance, it's generally okay for dev and test. You get about 2 nines of availability. With 2 instances, you get 3 nines of availability, and it's minimum required or recommended setting for production. Now, when you use 3 instances, you get 4 nines of availability, and this is a best practice that we recommend you use for production so that you can get 4 nines of availability, which is the highest availability you get within a cluster. Now, you can add more than 3 instances, but this is not going to improve your availability target. It will help to scale your read capacity. But again, the maximum availability target within a cluster you get is going to be 4 nines. And for that, you need a minimum of 3 instances. So the best practice, again, is to use 3 instances, which is 2 replica instance and one primary instance. The vCPU, or the compute, and the memory per instance determines your performance of the cluster. DocumentDB provides a range of instance classes to choose from, all the way from, like you see on the screen, 2 vCPU and 4 GB RAM for a T3 medium instance, to 96 vCPU and 768 GB of RAM for the R5 24X large instances. Best practice is to ensure that the indexes and working set fit in memory. And the cache size of the memory that is available to you is 2/3 of the RAM. The remaining 1/3 is used by DocumentDB processors and control plane and so on. So again, the best practice here is to ensure that you maintain your working set and indexes in cache. And when it comes to backup in DocumentDB, you cannot turn backup off. The minimum backup retention period is 1 day, and you can have a maximum backup retention period of up to 35 days. The backup retention window can be useful to trigger other automated process. Let's say, for example, you want to use the snapshot when it is created to build dev and test cluster. So you can say during this window, whenever a cluster is created or when a snapshot is created, go and create a dev and test cluster. And it takes about 5 minutes to get the live data to the backup. So you can recover from any time from 5 minutes ago until the backup retention period that you chose while creating the cluster. So you can do point-in-time recovery from current time minus 5 minutes all the way up to your backup retention period. Moving on, let's look at the best practices when you're connecting to DocumentDB from your applications. All instances will have an instance endpoint, but we will rarely connect to DocumentDB using this instance endpoint. What we will use instead to connect is the cluster endpoint. Cluster endpoint always points to the primary instance. So if a cluster is up, the cluster endpoint will point to an active node, which is the primary instance or the writer node. And if the primary fails, a replica instance is promoted to a new primary, and the cluster endpoint is updated to point to this new primary. Thus, when you use cluster endpoint, you can be sure to connect to the primary instance always for successfully writing data into DocumentDB. And in the DocumentDB console, you will also see something called reader endpoint. There is no real reason to use the reader endpoint. I'm talking about it because you might see this in the console. What reader endpoint does is, it round robins between the replica instances. And MongoDB drivers in a replica set mode, which I'll talk about in a bit here, will handle this in a much more elegant way. So the best practice is to always use the cluster endpoint when you're connecting to your DocumentDB cluster. And when you're connecting to DocumentDB, also connect as a replica set. Replica set is a Mongo multi-node concept. Using replica set allows you to connect to the cluster using any node, and the application will automatically discover the other nodes along with the primary node. So it can then leverage all these other nodes to perform read operations. Note in this slide, the cluster endpoint is in yellow color, and for when you're connecting using replica set, that is highlighted in green. Right. For now, the replica set is always named as RS0. We will discuss about the read preference that is written as secondary preferred in subsequent slides here. We will now discuss about the failover processes. Let's say we have a cluster with 3 instances, and the primary instance or the writer fails. DocumentDB will automatically failover. It will trigger a failover process to promote a replica instance to a new primary instance. And this process takes somewhere around 30 seconds or less. And DocumentDB will also spin up a new replica instance to replace the one that failed. So this will ensure that the cluster is returned to its full strength to meet your SLAs. And instance type determines the connection and cursor limits. The largest instance in DocumentDB, which is the R524X large, supports up to 30,000 concurrent connections. And this limit scales with the instance type you choose. And a couple places where we see folks get into trouble is when you're using driver that make poor choices about connection pooling. And it can eventually create many connections, more than what you really need. And also when you're using containerized applications, they are so easy to deploy programmatically And there can be many of them deployed, and you can quickly lose track of which instance is creating, or which application instance in this case is creating how many connections. And taking these two together, you can at times hit the connection limits. So we'll want to monitor this limit, and we'll talk about this during the monitoring best practices portion of this presentation. Cursors, they are like connection. They are also resources that should be, used, knowing that they're not unlimited. So cursors supported in DocumentDB are up to 4,560 is the current limit, and they also scale with the instance type. So the largest instance supports 4,560 cursors. And one way you can these limits get hit is when folks do not explicitly close their cursors, right? Open cursors are automatically reaped by DocumentDB when they are open and idle for about 10 minutes, but that's not a good way to manage the cursors. So if you are hitting the cursor limit, and then probably it's a good idea to talk to your application team to see if they're following good cursor hygiene and if they're closing the cursors appropriately. An example would be if you're using a programming language like Java or .NET, make sure that in your query, when you're running a query in a finally block, for example, just go and say close cursor, right? So this will ensure that the cursor is always closed. Again, just like connections, we would want to monitor this limit as well, and we'll cover that during monitoring portion of this presentation. So let's now discuss about scaling DocumentDB cluster. Reads that are supported by the primary instance provide read your own write consistency, or also known as immediate consistency, whereas the reads that are supported by the replica instances are eventually consistent. The latency between the primary and the replica instances are generally around 10 to 100 milliseconds. On an average, I would say it's about 20 milliseconds. And to scale reads, it is recommended that you use the replica instances. You can do so by using the read preference as secondary preferred. We kind of briefly touched upon it during the connection best practices. So using the read preference as secondary preferred will allow you to use the available read replicas to query your DocumentDB cluster for read operations. And if a replica instance goes down, when you use the read preference as secondary preferred, the read request will be directed to the next available replica instance. And what if that instance goes down, and if no instances or replica instances are available, then the reads will be directed to the primary instance, because you're saying the read preference is secondary preferred. So if secondaries are not available, generally it'll prefer secondary. If they're not available, it goes to primary. And let's say you want to scale your 3-instance cluster to support high read throughput. How do you do that, right? You can simply do that by adding more read replicas. You can add up to 15 read replicas. And again, when you're using read preference as 16 as secondary preferred, the driver will use these new replicas automatically. Especially when you say connecting using replica set and read preference secondary preferred, these will be automatically discovered. You don't have to make any changes to your application, and the driver will start sending or routing the request to these new instances that you add, allowing you to automatically scale your reads. And sometimes you need both levels of consistency in your application, like an immediate consistent read and an eventual consistent read. You can set the default and then override the read preference at a per query level. So in this example that you see, we set the default to secondary preferred because by default, we want to leverage the read replicas. And for stronger consistency, we set to primary for the queries that need them. And we do that explicitly on every query call. Right. In general, it is recommended to use homogeneous instances in a cluster, or using the same sized instances in a cluster, like R5 large in this example. However, if your workload has a on-demand or periodic analytical needs, for example, you want to run analytical report every month, right? This report could take more compute. And it's more analytical nature with a lot of aggregations and so on and so forth. What you can do is you can still right size your cluster for that online workload, and then add a node to perform this analytical operation. And in this case, as you see, the node would be, would be larger than your regular instances. Like instead of R5 large, it's R5 12x large, for example, in this case, right? You can run the reporting queries against this analytical node or instance, and then shut it down when you don't need it, because you're going to be running this report in this example like every month. So just shut it down, and then you can spin this back up again, because DocumentDB, DB's architecture basically, allows you to separate, storage, scale storage and compute separately, because they are decoupled. So adding this additional R5 12x large eventually would still take the same amount of time, which is 8 to 10 minutes, regardless of your data volume. So you can run this analytical queries every month, and right before whenever you want to run this, just spin that instance back up. So you can run asymmetrical workloads for these kind of requirements. And let's say our write throughput has increased, right? To scale our cluster that right now has 3 R5 large instances to R5 4x large instances, what we can do is add 3 R5 4x large instances, which is the destination that we want to reach to. And just to be safe, when you're adding this, you get an option to choose a promotion tier. You can choose the promotion tier to be a higher value, like a tier 0 for these large size nodes. DocumentDB will bias to choosing the larger nodes to become the primary should the current primary fail. And you can, once you add those 3 nodes, you can trigger an auto failover, and the larger instance will automatically be selected as the new primary. You can now delete those smaller R5 large instances, and you'll be scaled up, in this case, from R5 large to R5 4x large. So that's a good practice to follow if you want to scale up your instances in the cluster. And storage and I/O in DocumentDB scales automatically. Storage is scaled in 10 gigabyte segments all the way up to 64 terabytes. And the I/O scales automatically as well. So you don't have to worry about provisioning SSDs or EBS volumes. One thing to note is DocumentDB does not shrink storage. It uses a high watermark model. It will use the vacated space before allocating the new space down. So when you're migrating a large data set, and if you plan on deleting the data after migrating to DocumentDB, probably consider changing the approach and delete the data before migrating it into DocumentDB, so that you don't hit this, you don't pay the additional cost because of the high watermark model. And talking about monitoring now, DocumentDB provides more than 50 metrics at both cluster and instance level. And in this section, we'll look at some of the key metrics that I might want to consider to monitor DocumentDB performance and reliability and so on. It's a best practice to create billing alarms. Set 2 alarms, like one at 50% of your estimated spend and another at 75%. This will help you validate if your estimated bill is close to actual. And also using cost allocation tags is a good practice. You can get cluster level visibility on your billing when you use cost allocation tags. For example, if you want to determine how much you're spending on a monthly basis or whatever frequency you want to look at it as, right? You can determine how much you're paying for dev clusters versus test versus prod, and you can also then determine at per dev cluster within the dev clusters how much you're paying and so forth. So you can go fine-grained and figure out which cluster is costing you how much and make appropriate decisions. And then talking about the metrics itself at the instance level, the following metrics I would say should monitor at the minimum, like the buffer cache hit ratio. This tells you the percentage of requests that are served by the buffer cache versus what is served from the storage, distributed storage volume. And this value we recommend that you try to maintain a 95% or more, and trigger an alarm if it goes below 90%. Likewise, the next metric is the index buffer cache hit ratio, and this is the percentage of index requests that are served by the buffer cache. Again, just like the buffer cache hit ratio, we would like this to be above 95% and trigger an alarm if it goes below 90%. Database connections, these indicates the number of connections open on an instance taken at a 1-minute frequency. And database cursors are the number of cursors, just like the connections open on an instance, taken at a 1 minute frequency. And both of these connections and cursors, their limits, like we discussed earlier, they vary by the instance size. And it's a good practice to set an alarm when you're hitting like 80% of their limit, right? So if you're using R524X large, 30,000 is the connection limit, and 4,560 is the cursor limit. So set an alarm at 80% of these numbers, and see what is causing those increase in connections if at all you hit the alarm. And then freeable memory and CPU utilizations are just like any other EC2 instances. We don't like to see those getting near their limits and staying there for a longer time. So if you see CPU to be at let's say 80% and it's pegged at that number, then try considering scaling up. And then at the cluster level, you have DB cluster replica lag maximum. This is a replica lag between the primary and the replica instances. And the ideal value for this should be somewhere around 10 to 100 milliseconds. And the database cursors timeout, this tells you how many cursors have been idle, and hence DocumentDB read them off after 10 minutes. And if this number goes up, that means your applications are not closing their cursors. So you need to talk to them to see they can maintain a good cursor hygiene, to your developers, I mean. And then volume write IOPS and read IOPS. This measures what you're built for. There's not much to alarm on, but it's good for investigating any issues or behavior. And likewise, op counters, it tells you all the CRUD operations that are coming to this cluster. Again, nothing to alarm on, but good for investigating issues and behavior and understanding what your read and write rates are to this cluster. Then auditing and profiling are supported by DocumentDB, and to log the values in the audit and profiler log, you should enable them explicitly using the cluster parameter group. You can monitor DDL events, authentication events, role-based access control events. For example, you can see who's creating a collection, who's creating an index, and all that stuff. And you can create alarms and trigger notifications when any anomalies are detected. For example, let's say if you're getting a invalid authentication event 10 times in a row within like, let's say 10 seconds, you can trigger notification and see if anybody is trying to get into your system, right? And the profiler log, right? You can enable the profiler log and use it to troubleshoot slow queries. It will give you the query plan and what index is used and where the time is spent. So it's a very useful tool for tuning your queries and observing performance. Indexing with DocumentDB, right? So let's talk about some of the indexing best practices here. First and foremost, ensure that all your queries are using appropriate index. Create index on fields that are highly cardinal, because high cardinal fields, when you create index on them, it ensures that you have high selectivity. Ideally, we would want the selectivity to be 1% of your total data set. And it's always a good practice to limit the number of indexes to be less than or equal to 5. And if you see this number increasing, then look at opportunities to see if you can combine your singleton indexes into compound indexes, right? So those if you exceed that 5, then probably it's a good exercise to review and analyze what indexes you have and see if you can create more compound indexes as opposed to simple indexes. And as discussed earlier, during sizing, ensure that your indexes fit in memory. You can use index stats to determine the index size, like you see on the screen here, and determine the instance size that will fit this index in memory. And again, how you know whether it is whether the instance is sitting in memory or not, you can monitor the index buffer cache hit ratio to check if the indexes are scanned from memory or disk. And then you should use index stats periodically to determine the unused indexes and remove them from your collection, because unused indexes are gonna occupy memory and storage. It's gonna result in unnecessary cost and performance issues. So let's now discuss about how to optimize cost with DocumentDB. Right. So DocumentDB has 4 different pricing dimensions. The first dimension is the instance itself, right? And the cost for this is going to vary by the instance size. For example, if you're using T3 medium, DocumentDB will charge you 8 cents an hour. And the pricing precision is at a per second level with a 10-minute minimum. The second dimension is storage. And DocumentDB charges you 10 cents per gigabyte. Again, this is considering US East, but the cost is going to be comparable across the regions. And the third dimension is I/O, and DocumentDB charges you 20 cents per million IOPS. And any operation that takes place between the compute instance and the storage will result in an I/O. And if it is a read operation, docs up to 8 kilobytes results in one I/O. And for write operation, docs up to 4 kilobytes results in one I/O. So again, it's important to keep your document size at an optimal level. So we typically recommend to keep the document size below 8 KB so that your I/O cost is not increased because of the document size. The fourth pricing dimension is backup, and the cost for the initial data load is free, followed by 2 cents per gigabyte. For incremental storage or incremental increase in the storage in your cluster. Again, the reason the initial data load is free is because you cannot disable backup. So, by default, 1-day backup is enabled for you so that you can do point-in-time recovery at least for 1 day, and we don't charge you for backing up that initial load of the data. And one way to reduce cost when you're using DocumentDB is to make sure that your cluster is not over-provisioned. So you need to ask yourself this question and do this periodic review. Do you need all the replicas that you're using today? Consider your availability target. In your lower environment, do you need 4 nines of availability? If 2 nines is sufficient, maybe 1 instance is good enough, because keep in mind with 1 instance, you still get very high durability. And do you need a larger instance in a lower environment? Can a lower instance type like T3 medium work for you? Because that is going to, again, help reduce your cost. So basically look at reducing the instance size and reducing the number of instances, especially in the lower environment, to save on cost. And then you can also stop and start DocumentDB cluster. This is a very good option for dev and test clusters. So let's say your developers take off for the weekend on a Friday evening. You can stop the instances or stop the cluster and then come back on Monday and start it, right? So when you stop a cluster, you will not incur any instance charges. Since your data is still in the cluster, you'll continue to incur storage cost, and the backup cost is not going to increase because there's not going to be an incremental storage since there's no instance to accept writes. So you will save a lot by not paying for the instance when you stop a cluster. And the I/O, which is the third pricing dimension that we talked about, to optimize the I/O cost, ensure that the instance size that you chose fits the indexes and working set in memory. Because when working set and indexes are in memory, it increases the cache hit ratio and reduces the I/Os, which in turn reduces your I/O cost. And also, if your use case has TTL indexes to delete the data, be aware that those deletes are also going to result in I/O. If possible, use a rolling collection. For example, 1 collection a day, and then keep dropping every 8th collection if you want to retain data for, let's say, a week, right? You can, again, it's just a simple idea of grouping the data by collections and dropping the collection. Because when you drop a collection, there is not going to be an I/O cost. Again, this may not be applicable to every use case, but think about it. And if you can, then that will help you save some I/O cost. And define purge requirements and remove the documents that are beyond the retention period. Also remove unused indexes. And DocumentDB is an online, we use it more like an OLTP system, right? Online transaction processing system. It is not a replacement for a data lake or a data warehouse. So define purge requirements and delete the data that's beyond the retention period. And also, if you're using manual snapshots, make sure that you delete them when they become obsolete or when you don't need them, right? So you can select a backup retention period, and within that retention period, if you're creating a manual snapshot, DocumentDB doesn't charge you. But keep in mind that retention period is a rolling window. So as the retention period moves on, and if you happen to have a manual snapshot that is no longer in the retention period, you're going to be charged for that. So make sure that you delete those manual snapshots that are no longer required, because they're going to be like full backups. Yes, they are charged at S3 prices, but which is about 2 cents a gigabyte. But still, deleting the unused manual snapshots will help you to save cost. And the last topic on best practices is security. Right, so DocumentDB, as of today, is accessible within a VPC. And it's a best practice to limit the surface area of attack to DocumentDB by defining a security group such that only the application servers that reside in a specific security group communicate with DocumentDB, and that too over a specific port, which is 27017 over TCP. So this will ensure that you limit access to DocumentDB to known set of application servers belonging to a security group. And then DocumentDB supports username password authentication. Right? So when you create a cluster, you create a master username and master password. Do not use this master username and password for anything else other than creating cluster or admin users, right? And today, if you want the role-based access control in DocumentDB is at a cluster and a database level. And if you want to grant access to the collection, you can put the collection in its own database and grant access to that, right? So if you want to have fine-grained access at the collection level. But what is out of the box available is fine-grained access, or you can create users at a cluster and the database level. And as mentioned before, you can monitor audit logs for authentication events and permission grant options. Right? Cluster deletion protection is enabled by default so that we can help you to prevent accidental deletion of clusters. Of course, you can go ahead and disable it, but the default option is to enable it. And DocumentDB supports TLS for encrypting data over the wire and AWS Key Management Service for encrypting data at rest. With KMS, you can use AWS managed key, or you can bring your own key as well. And you get all the benefits of key rotation and the key policies that AWS KMS provides since it natively integrates with DocumentDB. And talking about native integration to DocumentDB, the other service from a security standpoint that we integrate with is Secrets Manager. And when you use Secrets Manager to store DocumentDB credentials, from an application perspective, the application will provide a secret name when calling the Secret Manager API, and Secrets Manager will return the credentials to access DocumentDB. You can also leverage the out-of-the-box capability that Secrets Manager provide to rotate credentials. And it is a recommended practice to leverage Secrets Manager integration to manage your database credentials so that you don't accidentally check in your code by maintaining it in the application layer and then checking it into GitHub or something like that. So again, integration with Secrets Manager is built in natively for you to efficiently manage your credentials. So that brings us to the end of this session. You can learn more about DocumentDB by visiting the link on the slide. Thank you all. In this section, we will discuss about migrations to Amazon DocumentDB. We will start with why customers are migrating to DocumentDB, and then discuss about the tools that are available to perform these migrations. We will talk about different phases that are involved in migration, and then also discuss the various methods that customers use to migrate to DocumentDB. We will then discuss the best practices to follow when you're migrating to DocumentDB, and we'll wrap up with a quick demo. All right, let's start with motivation. Why our customers are migrating to DocumentDB. Now, some of the reasons are listed on the slide, right? So DocumentDB is a purpose-built database service architected to support your operational workload, especially when your data is modeled as JSON. JSON by itself provides schema flexibility, and DocumentDB allows you to query data across any field in this JSON document, letting you to leverage the flexibility offered by JSON. Also, DocumentDB is architected for cloud, and it auto-scales storage and IOs so that you don't have to worry about provisioning EBS volumes or expensive SSD disks. DocumentDB is a fully managed service and has a consumption-based billing to help you reduce the overall total cost of ownership, or TCO. These are some of the reasons that we see why customers are migrating to DocumentDB. And we see customers migrating from various sources. Like most of our customers migrate from MongoDB, but we also see customers migrating from relational databases and key value stores as well. These are like most of the time, these are application modernization efforts. And we also see migrations coming from Elasticsearch, where customers have more than just text search needs, right? Where they want to do more secondary lookups based on different fields in JSON. For this conversation today, we will focus on MongoDB migration, though. Let's take a look at some of the tools that are available for migration. And AWS Database Migration Service supports MongoDB and many other relational database as source and DocumentDB as its destination. You can use DMS to perform a full load of your data and also replicate ongoing changes in near real time. DocumentDB is compatible with MongoDB, and hence to migrate data from MongoDB in particular, in addition to DMS, you can also use MongoDump to dump the data from MongoDB and Mongo Restore to restore the data into DocumentDB. Also, DocumentDB integrates with AWS Glue, and we have customers that use Glue to extract the data and transform the data from their source database. Generally, these are relational databases, and then they load this data using the Glue integration to DocumentDB. They load this data into DocumentDB. And it's good to understand different phases involved in migration. We'll talk about the various methods and how to do the migration, but let's level set our understanding on what are the different phases you should be considering when you're migrating to DocumentDB. So we recommend customers go through these 4 migration phases. Right? Discovery phase is all about figuring out your compatibilities. Right? Like while DocumentDB is compatible with MongoDB, there are some functional differences as well. And then the next phase is planning phase, where you would focus on how to do this migration, which migration method, which we'll be talking about in a bit here, suits you the best based on your situation, right? And the next phase is testing. As simple as it may seem, this is the most critical and important phase in migration, right? You should test your workload for not just functionality, but also performance in a lower environment, and then migrate into a production environment. And then the last phase is execution, where you bring all of this together and perform the migration based on the option you choose for migrating during planning, based on the test case you created during testing phase, and so on. And our docs cover these in greater depth, so please refer them at your convenience. So we'll double click on each of these phases a little bit more. Let's start with the discovery phase. During this phase, the primary thing you would be doing is, verify compatibility, right? Make sure that your application is compatible. Compare, the database version of MongoDB. DocumentDB supports and is compatible with MongoDB 3.6 and 4.0. Just make sure which version of MongoDB you're using today. The official upgrade path is, if you're on a lower version of MongoDB, you should go to let's say you're on a 2.6, then go to 3.0 or 3.6 with MongoDB, and then migrate into DocumentDB. We've seen customers migrating from lower versions of MongoDB directly into DocumentDB, and it has worked without issues, but we would strongly recommend that you test it thoroughly in a lower environment before migrating into DocumentDB from a lower version of MongoDB. And when it comes to driver version, generally the latest versions of the drivers are compatible. For example, you can use the driver version 4.2 with DocumentDB 4.0. Even though the server version is 4.0, the latest versions are compatible, and it would work just fine. Like I said before, we are not 100% compatible with MongoDB. We have some functional differences and some APIs that are not supported. So you should refer our documentation for details, because we document each and every at the operator and API level. We document what is supported and what is not. And I will discuss during the best practices portion of this presentation on how you can verify compatibility using some of the tools that we have built for you. Also, consider the deployment type for MongoDB before migration, right? So when you're migrating your MongoDB workload to DocumentDB, you will be using one of these deployment types, like standalone or replica set, or even a sharded cluster. To have minimum downtime with migration, it is important that you use oplog. And if you're using standalone deployment, then you must convert that deployment into replica set so that there is an oplog. And the easiest way to do that is just say rs.initiate command on a Mongo shell. right? And if downtime is acceptable for you, then you don't have to do this, right? You can just convert your standalone replica set using Mongo dump and restore that data into DocumentDB. And if you're using a replica set deployment, it is most straightforward and most common across our customers that we've seen. And you can migrate those replica set deployments using DMS, or you can also use dump and restore. And I'll talk about how you would use those tools just in a bit here. And let's say you have sharded clusters and you want to migrate from a sharded deployment into DocumentDB, and we have a lot of customers doing that as well. You will have to migrate those shards in parallel, as DocumentDB does not support sharding. And it is important that you size your instances appropriately, right? Understand what are your read and write rates at both peak and sustained loads, as this would determine the IOPS required for your cluster. And DocumentDB just builds you for IOPS, so it's important to understand those data characteristics. Also, talking about data characteristics, they do play an important role in your cost, because let's say your average document size, what is the current data footprint, and how does it grow, right? An example is you take the document size, and it has an impact on both the IOPS cost and storage, right? Because if you have a larger document to read and write, it's going to require more IOPS, and also the larger document result in, cumulatively, if you take all the documents together, it's going to result in more storage. Also, backup contributes to billing, and understand what your recovery point objectives are, and use appropriate backup retention period, right? Define those data retention requirements, because it's important to understand that how the data retention period requirements will drive the cost. It's always good to have that idea before you perform this migration. And I'll discuss best practice on how you can size your cluster later in this presentation as well. Also, be informed about the migration options, right? We'll discuss the migration methods in a bit. Depending on your deployment type, determine how to best migrate to DocumentDB using one of those migration methods. Oplog, like I said before, helps with minimum downtime migration, and migrations that can take a long time for the initial load. You need to be sure that the oplog is sized appropriately, because if the oplog is too small, you may cap the size on the oplog, and then new changes that are coming in may not be replicated, and you may be running into issues with migration. So it is very important to size your oplog large enough so that after the full load, the ongoing replications are migrated without losing any data, right? So those are the things that you look at during the during the discovery phase. Let's move on to the planning phase. In this phase, you choose your migration approach, whether you want to do an offline migration or an online migration, or a combination of the two, which is a hybrid migration. You'll also create your associated test plan as you wrap up your planning phase. And then during the testing phase, ensure that indexes are pre-created. Index creation in DocumentDB is sequential. So pre-creating index on an empty collection will be orders of magnitude faster. And then as your data is restored or replicated from DMS, those index updates will happen in parallel to keep up with the incoming data. And oplog, like I said before, size this to be big enough, before running out of oplog ring buffer. So how big enough should you size it, right? So if it takes, let's say, 5 hours to dump or do a full load of your initial data, then I would say size your oplog to be, twice that size. Size your oplog to size where it can take 10 hours of data. And to have minimum downtime migration, oplog is very important, and you must size it appropriately. And if you are, migrating from a sharded MongoDB deployments, ensure that you move the individual replica sets in parallel. Also, very important, turn off the balancer to avoid shard rebalancing during migration, right? Because while migrating sharded cluster, the data must not be rebalanced, and this is required so that you can avoid having orphan documents. And if the balancer, is on, then it can fail to move chunks of data, and this would leave documents on target shards as orphaned, right? And this can result in duplicate data during migration. You can certainly run a command to do cleanup if you have orphaned documents, but again, the best practice is to just turn off the balancer to avoid shard rebalancing. And If you do the first three phases right, if you take your time and make sure that you go follow these steps, then the execution phase will become simpler, where all that you do is follow the test plan, track the migration progress, and communicate the planned migration to your stakeholders, and then just simply go forward with the migration. So let's now discuss about the various methods available to migrate data to DocumentDB. The common migration methods, as I briefly touched upon earlier, are offline, online, and hybrid. For the online and hybrid method, you will be using the AWS Database Migration Service, also known as DMS. And you can use DMS free for 6 months to migrate data into DocumentDB. So the first method is the offline method, right? In this method, what you do is you can use Mongo dump and restore, and you can migrate very quickly. This method is super simple. It's fast, but it does have downtime, right? So if you can withstand downtime, then this is the best option considering its simplicity. In this method, what you do is your application, like you see in this diagram, stops writing to MongoDB as a first step. You then perform a Mongo dump on the source MongoDB cluster. And the next step is to pre-create your indexes in DocumentDB. This is a best practice and is recommended for all the migration methods that I'll be discussing today, which is going to be in the next couple slides. After you pre-create the indexes, you can restore the data into DocumentDB using Mongo Restore, and then just switch your application to point to DocumentDB. Now, one thing to keep in mind is during the steps 2, 3, and 4, as indicated in this diagram, the application is going to be unavailable. So that's the downtime I was referring to before. So Mongo, dump and restore, like I said before, it's a very simple approach. And if downtime is applicable to your workload, you can use this method. If downtime is not an option, then you can use the online method where we'll be using DMS. It is not overly complicated, and it also helps minimize downtime for migration, right? So in this method, the application will continue to use MongoDB. And like before, you would pre-create the indexes, create a DMS task using the database migration service, and you'll choose an option in the DMS task as full load and replicate data with CDC mode. Right? With this option, what DMS does is it performs a full load of the data that is in your MongoDB and loads it into DocumentDB, and then performs ongoing replication so that any changes that come in to MongoDB is automatically replicated to DocumentDB. And for this ongoing replication, DMS tails op log on the MongoDB source, and any changes that come into the source is replicated to the target. And after your replication is caught up, all that you do is switch your endpoint in your application to point to DocumentDB. Right? MongoDB source and DocumentDB in this setup can be run in parallel as long as you need and you're comfortable to make the cutover. And talking about downtime, the only downtime is when your application cuts over from MongoDB to DocumentDB. When you make that switch of endpoint, that's the only downtime we are talking about. And the hybrid method, which is the third and the final method, it combines both offline and online approach together. So it brings the goodness of offline and online method together. This is faster than the online method, but requires a little bit more setup. So it has very similar to online method. This has near zero downtime. And the additional setup here is because you have to do both Mongo dump and restore and use DMS. So let's talk about how that works by walking through this diagram. So again, the application continues to use MongoDB, and you will use Mongo dump to dump the data from MongoDB, like the first approach, the offline approach. And then you pre-create indexes. This is common across all the approach. And then you restore data into DocumentDB using Mongo Restore, right? Since full load is done using Mongo dump and restore, when you're using database migration service, you would enable replication with CDC mode only. Whereas in the online approach, we said full load and CDC. Here, we are going to just say enable replication with CDC only. And like before, after the replication is caught up, just switch the endpoint to point to DocumentDB. And again, the downtime is going to be the cutover time from MongoDB endpoint switching to DocumentDB. And now let's talk about the best practices for migration. I'd like to start with some of the homegrown tools that the specialist solutions architect like myself and my colleagues have built to help our customers. These tools are not officially supported by AWS, but these are helpful for you to do things like compatibility. So let's say you want to verify compatibility. We have put together a tool that will parse your Mongo logs and let you know if there are any operators that are not compatible. Right? And if you want to do sizing and estimate pricing, we have a calculator that accepts the data characteristics as input and provides the sizing and pricing information for your workload as an output. This is a good information and a good place to get started to start performance benchmarking your cluster and determine your scale needs if you want to scale up or down from there, but you get a good starting point. And to help with index compatibility assessment, we have a tool that parses your index in MongoDB and provides information on incompatible indexes if there are any in your cluster, in your MongoDB cluster. This tool also provides you an option to pre-create indexes in DocumentDB. And in addition to compatibility and sizing, like I said before, it is very important that you size your op log to capture all change events during the migration. So your op log should be big enough so that after the full load, any changes that had come during the full load and after, your op log is sized to capture those. Right? And to speed up migration, you can scale your primary instance in DocumentDB and then scale it back down. This will give you more compute to process additional writes. So you can increase your write throughput and take more writes per second. And then after the migration is done, you can scale back down, right? And if you're using Mongo dump and restore, you can set the num insertion workers per collection to match the number of vCPUs on your primary instance. This will speed up the migration because what this does is it lets you leverage the parallel execution of threads while restoring the data. So you can restore data in parallel across the available compute on the primary instance. And it is very important that you remove the unused indexes and the data that is beyond the retention period prior to migrating data into DocumentDB. DocumentDB follows a high watermark model. So let's say you have 10 terabytes of data and you cleaned up 2 terabytes of data after migrating to DocumentDB. The high watermark model based pricing will charge you 10 terabytes and not 8 terabytes. While no additional cost will be added until the 2 terabytes data comes in, you can certainly save costs by deleting the data before migrating into DocumentDB. Lastly, testing is not optional. It's very important that you perform testing in a lower environment before migrating your workload and be up and running in a production environment. So with that, let's take a look at a demo. So we'll look at the second approach that we discussed today, which is online migration from MongoDB to Amazon DocumentDB. I'll just quickly walk you through the DMS configuration and show you how this migration works. All right, so I'm here at at my AWS account, and I'm at the database migration service. So if you look at this, I'm at the Endpoints tab, and we have 2 endpoints here. I've predefined the endpoint. So what I have here in my setup is I have a MongoDB instance running on EC2. Which is a very common setup for our customers, where you want to migrate MongoDB running on EC2 to a fully managed database service like DocumentDB. So this EC2 instance is running MongoDB. It's a very simple setup. And in DMS, I first define a MongoDB source endpoint. Let's look at what this endpoint looks like, right? So I have configured this as a source endpoint, gave it an identifier, and you chose the engine as MongoDB, right? So you can see that you can choose other engines as well if you're coming from a relational database or whatever. But in this case, we are doing a migration from MongoDB. So the source engine is selected as MongoDB. And I gave the name of the server, the port, and I did not enable SSL on this just because it's a demo. And then I have given a username to access the database and a password, and the authentication source is the admin database in MongoDB, and the database that we're trying to migrate is LabDB. And that's pretty much it for the MongoDB source endpoint. The other endpoint that I have created is DocumentDB target endpoint. And like before, let's go ahead and modify this and take a look at what this endpoint configuration looks like. So it is configured as a target endpoint. The target engine is chosen as Amazon DocumentDB. So we are migrating from MongoDB to DocumentDB. So we've chosen the target engine here as Amazon DocumentDB, and back there as in the source as MongoDB. And I'm giving my server name, which I'll show you in a bit here, which I've already pre-created this cluster. And then this one I have created with SSL so that you can see what the SSL configuration looks like. I'm saying verify full, and I've given the certificate as well. And then I give the credentials, my username, and the database that I'm trying to migrate to. And that's pretty much it. So those are the endpoint configuration. The other component we need is a replication instance, which basically is the one that is going to do the task of reading data from MongoDB and writing it into DocumentDB. So let's look at what this looks like. It's a very simple setup. You just give the name and choose an instance type. So you can choose like in this case, it's chosen T2 medium, but you have a lot of options here to choose from depending on what workload you're migrating. Right? You can also choose to have multi-AZ deployment if you want high availability, but since this is a demo environment, I chose not to. And that's pretty much it. The other one before we move off of this is a security group, right? So I have given a security group called Migration Lab MongoDB Access. This is important because if you recall, when I was talking about the best practices, it is important to limit surface area of attack to your DocumentDB cluster. So in the DocumentDB cluster creation process, I gave a security group which will allow access from this security group. So in other words, this replication instance is now going to be able to talk to DocumentDB because of the security group configuration that I've created for DocumentDB, which I'll walk you through as well. So actually, let's go and take a look at that security group and come back to this. So I'm going to go to the security group section over here, and you can see that the MongoDB migration access is the security group created, and I also have a DocDB security group. And if I look at the inbound rules for the DocDB security group, it has this migration lab MongoDB access as one of the inbound rule, and it also has a Cloud9 environment as another security on another rule here. So in a nutshell, the DocumentDB cluster that I have will allow access from this Cloud9 environment as well as from any instances that have the MongoDB access, Migration Lab MongoDB access as its security group. Right. So those are the inbound rules for my DocumentDB cluster, and here is my DocumentDB cluster, and you can see that the DocDB inbound rule that we just walked through is associated to this particular cluster. So that's about the security group configuration. So let me go back to the DMS service, and so far we've created 2 endpoints in a replication instance. So now what we're going to do is through the migration task, tie them all together, right? So you can see that I have a DMS task created over here. And you can see that in this DMS task, I'm saying do nothing for the target table preparation mode because I'm just going to replicate whatever is there in MongoDB. And after the full load completes, I'm saying don't stop because I'm going to be migrating data, not just for full load, but also replicate ongoing changes. And then at the end, I'm also leaving this limited LOB mode to the default of 32 kilobytes. So that if there's anything more than 32 kilobyte, it will not include those in the replication. And you can also here you see that in I've written a selection rule saying that hey, LabDB is my collection. Sorry, the database. It has like 2 collections in it. So I'm just saying take all of them and include them while you're doing the migration. So migrate this database with all its collection into DocumentDB is what I'm saying. So and if you look at this migration task, the type is full load with ongoing replication, which is again the online approach. And the MongoDB source endpoint is associated to the source, and target over here, and the replication instance that we walked through is over here. So all of the three components we created, the task ties them together and defines the type of migration, right? So in this case, full load and ongoing replication. So before I go ahead and start this task, which will start replicating data from MongoDB to DocumentDB, I want to show you that I'm at the Mongo shell here pointing to DocumentDB, and I want to show you what databases this particular cluster has. So I'm at the getting started cluster that we just saw, and I have three databases: case, catalog, and YCSP. And the database I'm trying to migrate from the MongoDB instance running on EC2 is called LabDB, which is what my task over here is configured to do. So I'm going to go to this task, and I'm going to say, start or restart or resume. Since I already have this task, it gives me an option to restart or resume. So I'm going to restart this task and say start, right? And you can see, that this task is it'll be starting in a moment here. As you can see, the status after I refresh change to starting. So this task is starting, and in a moment it will change to running, right? So what it does is it initially performs the full load, and when it completes full load, it will say full load complete and performing ongoing replication. So those are the various status. So from start, it should change to running. There you go. The status is now changed to running. So again, if you look at this, it is loading data into DocumentDB. And we can also go to DocumentDB and see if the new database called LabsDB is created. And you can see that the database is created. Yes, it is still performing the full load migration, but we can go and look into it to see what data it contains. So I'm saying use LabDB, and let's look at what collections this has. This has customers and locations as two of its collections. So I'm going to say db.customers.find one. I'm just running a MongoDB command to see if it is really bringing in the data. So yes, it is bringing in the data as well, right? So you can see that the migration has started, and it is performing full load. And you can see that the rows are now incrementing. You can, if you keep monitoring this particular table, you can see it's been about a minute 32 seconds since the load lapsed, and it will continue to load the data. So after it completes the full load, which will take about 4 to 5 minutes, the status will change to replicating ongoing data, right? Full load complete, ongoing replication is what the final status would be. So yeah, again, when I refresh, I see that the new rows are now shown over here. So that's about what I wanted to cover in the migration demo. So again, the real quick summary of what we saw. We looked at the endpoints, MongoDB source and target endpoints, and we looked at the replication instance that is used to read from Mongo and write into DocumentDB, and how the tasks ties them all together, and how when you start the task, it starts doing the full load migration, and after it completes, you would be eventually seeing that it will do a ongoing replication. So let's go back to the presentation. The last slide I just really have is I wanted to really thank you for your time and attention. And I appreciate you guys spending time to learn more about DocumentDB and how you can migrate into the service. Please let us know if you have any questions or any feedback. We are always active on our forums. So with that, I'll thank you again, and take care of yourselves. Bye-bye.